Okay, guys, so what we're going to be working on today is we're going to be working on graphing the sine function. So this entire unit is all about visualizing sine and cosine. We know a lot about them, but we want to know specifically what they look like. So what I'd like you to do first is you have this grid in front of you. I want you to label the x-axis with negative 2 pi, negative 3 pi over 2, negative pi, etc. Start with labeling that, and then I want you to draw a blank unit circle with these four ordered pairs. So start with that. Okay, so now that we have all of our x-axis labeled, I want you guys to think about specifically the sine function on the unit circle. So here's what I want to think about first. The first point that I want to think about, in fact, maybe I'll make a little table here, is I want to know, okay, what is sine's value? Maybe like what's sine's value specifically at x is equal to 0? So let's start with that. So say we have sine of theta is our y, x is our x value. At 0, we know that sine of 0 is equal to 0. And so that means that on my graph at 0, I'm going to be at a height of 0. So go ahead and put a ordered pair at 0, 0. In fact, you can see that on the unit circle. At 0, you guys can see that we're at a height of 0 on our unit circle. So let's move on to another ordered pair. Let's try pi over 2. If we try pi over 2, sine of pi over 2, well, sine of pi over 2 is 1. So at pi over 2, we should be all the way up here at 1, and let's label that. We'll say that's 1. Notice here how if I'm using sine on the unit circle, I'm going to start off at 0, but once sine gets up to pi over 2, I should be at a height of 1. So you can kind of see that sine is getting bigger, 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 and then you're going to kind of predict that sine's going to get smaller next. So let's try the next one. At pi, we're going to have sine of pi. And sine of pi, we can see, is 0 again. So at pi, we're going to have an ordered pair of pi, comma 0. Let's keep going. What about 3 pi over 2? Well, the sine of 3 pi over 2, we can see on our unit circle here, is negative 1. So our pattern's changing a little bit. So as I go around the unit circle, sine starts at 0, goes up, 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 back down to 0, and then down to negative 1. So at 3 pi over 2, we're going to put an ordered pair at negative 1. Lastly, 2 pi. All right, so I want to know what's the sine of 2 pi. Well, sine of 2 pi is if I continue to go this way, I'm actually going to be back at 0 again. So sine of 2 pi is 0. What I want you to do next is we're going to connect this with a smooth curve. Specifically, we're going to use the word concavity. The first curve, the first half, is going to be what's called concave down. So it's kind of like a parabola opening down. The second half, starting at pi to going to 2 pi, is going to be concave up, which is going to look something like this. I want you to see if you can extend this pattern, because this is in fact a pattern, to the negative half of the quadrant. Okay, so by extending this out, you guys can see that there's actually like a mirror reflection that's happening here. So the next point you're going to get is at negative pi over 2, comma negative 1. The next one's going to be at negative pi, comma 0. The next one's going to be at negative 3 pi over 2, comma 1. And the last one is going to end up at 0 again. And so you guys can see that there's like a mirror reflection over the y-axis happening here. This is the official graph of sine. And this goes on forever and forever and forever, right? To the left and the right, I can continue going on this direction. So sine has some really awesome properties, and I want to define them more formally. The first word that I want to define is something called the amplitude. So something called the amplitude. The amplitude of the graph basically tells you how high the graph is. So before I give you a formal definition, I'm just going to show you what the amplitude is. The amplitude is the distance from what's the middle of the graph. In fact, let's give one more definition. We'll also define midline. So we want to define real quick the midline. The midline of the graph is going to be the graph that splits this graph exactly in half on the horizontal axis. So in this case, the midline is going to be the x-axis. You can see that this blue line splits the graph exactly in half horizontally. So the amplitude is basically the distance from the midline to a max or min. For example, the distance from the midline to this max is 1. But we can also see over here the distance from the midline to this max. We can see that distance is also 1. And so the amplitude is always the same no matter where you go on the sine graph. We can see it's the same here, and it's the same here, and it's the same here. And remember, distance is always positive. So even if I'm below the x-axis, think distance is the absolute value. It can't be negative. And so what we can define amplitude as being is this. We can say that amplitude, let's see if I can scoot this myself. We can say that amplitude, in essence, is the distance, and remember that that's positive, between the max slash min and the midline. Okay, so the amplitude is basically how tall does this thing get specifically from the midline. All right, and remember the midline right here, we'd say it splits the graph in half horizontally. Okay, one more thing that I want to add, and this is also a really important piece of this graph, is something called the period. So the period of the graph basically tells me how long until the pattern starts over. So how long until the pattern starts over? I want you to look at the graph and think to yourself, how long on the x-axis, or how many x values do I need until this graph starts over? So take a look at that, see if you can guess that first. Okay, so looking back at this, we want to figure out how long until the pattern starts over. Well, here's what I want to see. I start down at 0, and then I go up, 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 come back down, 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 continue to go down to a minimum, come back up to the midline, and we can see that right about here is where we stop. So notice here, I started at the midline and I was going up, hit a max, went down to the midline, went down to the minimum again, and came up to the midline. So we can see that this segment right here is going to be a repeat for the rest of the function. You can see it here. Here's the same segment. Up from the midline, down to the midline, down to a minimum, up to the midline. So we can see that this segment right here is just going to be repeated over and over again. Specifically, the distance that it took me to repeat this segment was pi over 2, pi, 3 pi over 2, 2 pi. So the whole distance that it took me to complete this cycle was 2 pi. And so we'd say that the period equals 2 pi. It takes 2 pi distance, or you could think like 360 degrees, to start over, which totally makes sense. If you guys think about your unit circle, look at sine. Sine starts at 0, it goes up to 1, comes down to 0, comes back down to -1, comes back up to 0. It does all of that in 2 pi radians. It does that in 360 degrees. So graphically, it should be no different. In order for me to start over, it should take me 2 pi radians. In fact, you can see that down here. The unique segment that we see is also 2 pi radians down here. And so this is the sine function. We're going to do the exact same process for the cosine function. We're just going to do it a little quicker. Okay, so for the cosine function, we're going to move a little bit more quickly here because we understand how the sine function works is the same way that the cosine function will work. First thing we're going to do is think, okay, cosine of 0 degrees or 0 radians gives us 1. So at 0, you guys are going to go up to 1 and put an ordered pair, right? So this is going to be 1, this will be -1. From there, cosine of pi over 2, we can see is 0. From there, cosine of pi is going to be -1. From there, cosine of 3 pi over 2 is back at 0. And lastly, it's going to end again because its period's the same. Cosine of 2 pi is going to be back at, I think I messed this up. Give me 1 second. No, I think we're good. Cosine of 2 pi, we can see right back here, we're going to be back at 1. So you can see this graph is really similar. It's not quite the same. Here's how we're going to graph it. Start with drawing something that's concave down to connect the first 2 dots. Then switch to being concave up for the second 2 dots. And lastly, concave it down again. So this is going to be the unique pattern that happens over and over again for cosine. It still has a period, notice, it still has a period of 2 pi. So let's continue the pattern. To continue the pattern, I'm going to go to the left. I'm going to go down instead, go over like this, go back up like this, and we'll end back up 1 here. Okay, so we can still see the period is 2 pi. The amplitude you can see is also the same. So first thing I'm going to do, I'm going to highlight my midline. My midline is still the x-axis here, and so to find the amplitude, I'm going to find the distance from a max to the midline. So you guys can see this distance is 1. We can see this distance is 1, 1, 1. You actually only need to test 1. And so we can say right off the bat that the amplitude is going to be equal to 1, while the period is still going to be equal to 2 pi, just like last time. So this is the cosine function. Okay, so let's do a couple of quick practice problems using these base functions. All right, so real quick before we do that, I want to talk about some generic sine and cosine formulas. So one generic formula we might have is something like this. A cosine of bx plus c plus d, or you could have a sine of bx plus c plus d. So what I want to talk about here is what do each of these represent? A is going to represent, in fact, let's use the same colors that we did before. A is always going to represent the amplitude. And real quick, if you guys need an amplitude definition again, we'd say amplitude is the distance between the midpoint and a max and min. So real quick, A is the distance between the midpoint, midline, and the max slash min. And remember, it's always positive. So amplitude can't be negative. Okay, some other ones are a little bit newer. Let's do a couple more. Next one, when you see this b value, b is actually really important. It has a lot to do with period, which we're going to talk about later. We can say that the period of a function is always going to be equal to, at least for sine and cosine, 2 pi over b, which we'll talk about later, but it's nice to have written. Next, this entire piece, the blue piece as a whole, so taking it in as a whole, all of bx plus c, that's going to tell me about moving left slash right. So that's going to be like a horizontal shift. We call it technically a phase shift, which we'll talk about later. And lastly, d plus d, that's going to be what's called a vertical shift. That's no different than any other function. So that's like a vertical shift, right? So that's like up and down. So vertical shift, same thing as up slash down. All right, so let's try one example problem. Okay, so taking a look at these examples here, we're not going to really use the table as much as I did anticipate. So all we're really going to do right now is we're going to try to identify what is the amplitude in all 3 of these graphs, and we're going to try to graph them all together. Okay, so the first thing we want to do is identify, okay, what is the hidden number that's multiplying to sine? Well, that hidden number is 1. And so we can say the amplitude of sine of x is 1. The amplitude for a half sine of x is going to be the number in front of sine of x, which is 1/2. And lastly, the amplitude of 2 sine of x is the number in front of sine of x, which is 2. Okay, so let's try to graph sine of x first. So what I want to do for this next section is we're just going to graph sine of x in black, and then I'm going to graph 1/2 sine of x maybe in green, and then I'm going to graph 2 sine of x in blue. Okay, so let's start with our first one, the base function, sine of x. We're just going to graph this like we did before. We are going to first label our axis, right? This is pi over 2, pi, 3 pi over 2, 2 pi from our labeling before. And we know that sine started at 0, 0, and then it went up to 1 at pi over 2, and then it came back down to pi, came back down to -1 at 3 pi over 2, and then it came back up to 2 pi. So this is the original sine of x function. It's like the parent function. So what I want to try to do next is figure out, okay, what in the world would, in green, what would 1/2 sine of x look like? Okay, well, 1/2 sine of x should in theory be the exact same function, but it has to be shorter. So here's what we're going to do. We are going to take all of the y values that we see and we're going to multiply them by half because we want our height to be half, right? We want our amplitude to be half. Well, the first height that we see at sine at 0, well, 0 is a height, and 1/2 times 0 is 0. But our next one here, we see that this is a height of 1, half of that would be half. So instead of going up to a maximum of 1, we're now going to go up to a maximum of a half from the midline. Remember, our midline was this right here. Okay, and then we're just going to continue. We're going to come back down, and technically we can't change the height at 0, right? The height at 0, 0 times a half is 0. So that stays the same. We're going to come back down again to 3 pi over 2. Its height, or its distance, was originally 1. Now it should be half of that down here. And then come back to 2 pi. And so we can see that the green sine function is really, really similar to the black sine function. The only difference here is that its amplitude is slashed in half, right? So it's getting not as tall, right? The tallest that it gets is a half. The lowest that it goes is negative a half. And so it's the same function. Okay, let's try the last one. 2 sine of x. We can kind of anticipate what this is probably going to look like. 2 sine of x, okay, let's think. We start at our first value right here on the x-axis and the y-axis. If our height was originally 0 at the y and x-axis intersection, the origin, then 2 times 0 is just 0. It stays at the origin. If we go to pi over 2, though, our height is no longer going to be 1. It needs to be 2 times that, 2 times 1. And so we need to make our height go all the way up to 2 this time. Coming back down to pi, we think our height was originally 0. 0 times 2 is still 0. Coming down to 3 pi over 2, our height or our distance was 1, or we said we went down negative 1. Now we're going to have to go down negative 2, like this. Lastly, when we end at 2 pi, we're going to end here at at the midline again, because 0 times 2 is still 0. So if we try to connect that with a smooth curve, sorry, my hands are a little shaky, we should get, oh no, that does not look good. We should get something that looks like this. So it's the same sine function. This time it gets a lot taller. In fact, it's taller by a factor of 2, or more specifically, its amplitude is twice the amplitude of the original. Okay, so these are our 3 functions. We're going to stop there for today. And tomorrow in class, we're going to go over more details about graphing sine and cosine, more specifically, graphing the period.